first week of using the Surface, I think that my battery lasts the entire full day, so I was satisfied. And the week after, it's almost the zero. When I finished the last lecture of the Tuesday, I have 3 classes the Tuesday. Last week, it lasted up to this course, the operating system. I can cover the database and operating system this week. So after one class, it's almost 10%, less than 10%. I don't know what happened. Is it because of I insert the many applications? I don't think so. But anyway, huge problem. Okay, so I think nowadays even the mobile device, they try to put the battery, built-in battery. You cannot. This one can be replaced, so I can replace the battery. But nowadays, most of the mobile device, including Galaxy, I think the new version of the Galaxy is a built-in battery, right? Yeah. You cannot replace it, like the iPhone. They too much compete with the the thickness of the device. But I believe the main problem of the mobile device is the battery power consumption. So that unless addressing the battery problem, they cannot. Why don't you take the power or the energy class in the electrical engineering rather than the operating system? You probably can make much more money. And also nowadays in the computer science, hot topic is how to handle the big data. Have you ever heard about the big data system? No? If not, I think that's the problem. So why don't you read the article or you can even I offer the couple of the big data courses, including big data analysis, and another one is a NoSQL database. But even though you are not interested in very much for the big data, as a computer science student, you'd better know that. Then, what is the main component, the main framework of the big data system? Is there anyone who knows? When we are saying the big data, what do you think? What can you imagine? Big data. Have you ever heard about the Hadoop? Yes. What is a Hadoop?
File system.
It's a name of product. Okay? And also, who named this one? Anyone? So one of the engineers from the Google, whose name is Doug Cutting, Doug actually named the system. It's a big data system named after what? Toy. His son's toy, his name is the Hadoop. It's an elephant, the toy. So he named the new product as the Hadoop. Actually, it's his son's toy's name. But Hadoop, what is a Hadoop? So he answered, Hadoop is there are 2 main components. By the way, before that, why do we need a Hadoop? Long time, it's not long time ago, the beginning of 2000. Do you think how big of the data size in Google system? Google has the database probably. How big is that? It's huge, right? And also, how long it takes to search the data using Google? How long it takes? You can just search right now. It takes less than a second, right? It quickly returns. Considering size of the Google data, it's quickly returned, right? Do you think of how Google makes such a fast the retrieval time. Probably they will use something indexing structure. As some of you guys already took the database course, and some of them are taking the database course. So if you are taking the database, one of the ways to make the efficient search is what? The indexing. You can use the index to speed up to search the data. Google probably used such an indexing structure. Also, even index cannot solve all the problems. Google has their own file system. They realized that if they are using the traditional file system that we have discussed last few days, they cannot manage huge number of the file. By the way, let's go back to the beginning. How does Google work? How does Google work? Have you ever think about? No? Just use the Google. The Google changed the algorithm, by the way, recently. Searching algorithm that focus on mobile platform. So that's the different story. But who knows? Some of you guys will start your business. You need to think about how can you make your web page at top of the Google search. Then at the time you should know how Google search engine is working. But that's a different story. But think about how does Google work overall. Google collect what? Web pages. How can the Google collect the web page? It's a very simple algorithm. It's not algorithm, very simple platform. First, you can start one page. My page, JELE. It may have hyperlink, right? Like the UV, or some of my students. So link. So first, visit one of the page that's called the seed page. Okay, starting from the seed, then this web page is a document. This document will be saved in their copy, this file, and saved in the Google Story. Okay? Then visit this one, and save. And this one may have the several link, hyperlink, URL. Using this one, save. That's it. That's called crawler. As if you are crawling. So you can crawl the web pages, World Wide Web. So what Google is doing is very simple. Visit the web page and save it. Visit the web page and save it. Then Google search, if you type the Professor Lee's name, how does it work? Check all the web pages. Then return web pages that include this one. That's it. Then you can make the Google search engine. Right? But the problem, how many web pages you have in the Google system? It's huge. Million, much more than million. Trillion, the web pages. So it takes a long time to search the document. So at that time you need what? Index. Mostly it's called the inverted index, which is one of the projects in this master big data system. So you can make something index. We are not going to discuss details about it, but using such a thing, you can return the web pages here. But this one is too big to manage. Huge. Sometimes they need to think about the temperature of the server because they have so many temperature. So they need to cool down. So to save the energy, they build their storage in the North Pole. Really? So that is the one of the evidence how big the Google data. So traditional file system, UFS or the GFS or the something ext1, 2, we cannot use such a traditional file system. First reason is too many files. Also another reason is most of the files are document. Okay. Also, it takes a long time to process certain operation. To address that problem, Google actually, including the dog cutting, they developed a new file system which is called the Google File System. Google File System basically is a distributed file system. Distributed file system means the traditional file system is this is the computer. We have the hard disk drive. To manage such a hard disk drive, we need the software that includes the file structure, directory structure, and file attribute, the file operation, and directory operation that and also format, the hardware data structure. Including that, we have the file system. So this doesn't work with such a huge amount of files. So Google File System, what if we have such a distributed file system? However, they do not replace the existing file system by the new Google File System. Instead, their files, what is a file system, by the way, according to the definition? It's a software to manage the file. It doesn't have to be the new software. You can implement, you can make any program that manages the file. That is a file system. Okay? You can open the file, you can read the file, you can search the file, then that is a file system. So Google File System is on top of existing file system. For example, the UFS running on existing file system, that is also file system. Okay? So after Google announced their successfully implemented and applied to their server, then they release the source code and the algorithm of such a Google File System. Then they make the cutting. Actually, the quit their job, his job from the Google. Then belongs to the Apache Foundation. Apache is the open source. The community, they develop HDFS, named Hadoop Distributed File System. It's originally from the Google File System. Okay. So, what about this one? This is the same as Google File System. It's running on top of the existing file system. Then it's a different software to manage what? Each file. So, file system itself is not the new one. It's not very complicated one. So even you can develop the file system. You can make your own file system using the C++ or the .NET, C#. So I try to manage my own file, okay, to search quickly. Then that is your file system. This is very hard to make the student understand the concept of the file system. I realized that last semester. So last semester, I offered a project to implement portable file system. Portable file system, in this project, the student needs to implement a simple file system that can create the file, okay, search the file, and directory structure that we have discussed in the last class, in the file system file data structure. This is running on any operating system. It's a software application program, but focusing on managing the file. But none of the students understand. Even many of the students understand the concept of the file system during the demonstration. So I believe this class may be the similar or the same. Even though your response may be understood, but file system is nothing special. Okay? It's also operating system is what is operating system? It's a software, right? Running is an interface between the machine and human being. Using that software, we can actually order or run any other application. File system is a part of the software nowadays. It tends to get away from the operating system. So it's kind of the separate application level, the file system, but that is running on top of the operating system. Also, it can be running on existing file system. So we are going to discuss today how to implement such a file system. So after the chapter, you should be able to develop your own file system. Really, it's not. It's the same program. Please, the file system itself is nothing special or the system programming. It's the same as the application program that you have developed in your programming class. But objective of this software is what? Managing the file. You can create your own file. You can to do that. What do you need? To create your own file in your program. What do you need? What do you need if you want to create your own file in your program? Which one? Anyone? Data structure. You need to design. That's the most important. Without the design, you cannot create it. So my file default size is 1K, for example. And 10%, 100 megabyte will be used for header. That will be used for file information. How many blocks are there? And what is a file descriptor? What is a file name? Okay? What is the permission that we have discussed last time? So you need to design that in your software. You can create a function to create a file by following such a data structure. That is your file system. So we will discuss today how to implement such a file system. So which means it can be your homework to implement your file system. But I realized, I believed before that, until that time, the student can understand easily the implementation of the file system. But many of the students are afraid to understand such a concept of the file. It's the same as your application program that you develop, that you did in your programming class or software engineering class. But it is focusing on the file itself. Okay. That includes, yes?
If we have the file structure over on top of another file structure,
yes,
as operating system, then the top level takes the priority.
Top level is the priority for user interface. So users should know how to use your software. They don't have to worry about the base operating system.
Do we still need the file structure that is in the operating system, or we can skip it?
No, you cannot skip it. Your operating system should provide sometimes the common API, how to read the data, how to write the data. We will see. Yeah. Because as we have seen before, there are in one operating system, how many file systems? There are so many file systems. But your operating system should provide such a common basic operation that are needed in the file system. So to do that, we will discuss about such a structure. As I said, data structure is the most important part. Everything can be explained as a data structure. Okay, so such a data structure, then how to implement such a file and directory, then physically how to allocate. Okay, I'm going to explain this chapter based on the experience on the last semester project. Okay, we pretend to implement the portable file system here. Okay, so file structure. Is it physical level or the logical level? It's a definitely logical level. That is the first thing that student cannot understand. What is a file? Okay, file is your definition. If you want to develop your own file system, you can design. This is the file. Okay, Microsoft Word. When Microsoft Office develop the Microsoft Word, they define that this is the DOC file. This is the DOCX file. That includes the first, the 10 byte is for the file descriptor. Next 10 byte is for, so it's the rule. It's a design, it's a data structure. Similarly, it's a file system. File structure itself is the logical storage unit. It's a logical. What is a physical level? Binary, can you remember that basic unit of I/O? It's a block. Okay? And even before the block level, what did we discuss? Cylinder number, sector number, and so on, track number. That is the lowest level. It's a really physical level, but you don't have to worry about. But block should be defined by your operating system. So using block ID, you can access data. But when you implement a file system, you don't have to worry about the physical level. Instead, the logical level you need to design. Okay. So anyway, file system is not in the memory. There exists a memory-based file system nowadays. However, at that time, even though you use the memory, something special, memory as a file system, that doesn't mean file structure is changing. In terms of file structure, you still use, you do not use the memory structure. You still use the file structure for your memory file. Okay? So so that is the reason it's a file system still reside on the secondary storage or disk. Then file system. So first time when we implement so let's say that our operating system use NTFS. Okay, NTFS is very popular for the very popular file system used in the Windows. Okay, right? So if I ask you, why don't you develop the portable file system? Okay, running on existing NTFS file system, what do you guys need to do? You should have the something storage. In terms of NTFS, what is the storage? It's the OS, the NTFS file. Okay, for example, this is the abc.pdf file. This is your storage as a file because it's running on existing file system. If you implement a real file system based on the hardware level, your file will be created on top of low device using what? Hard HDD 0 and cylinder number 1, sector number whatever. Okay, but that is a low level. You don't have to existing file. NTFS, you can create a file, but that file will be managed by this one. Okay, at that time, you need to design data structure of each file. So file consists of several blocks. So each block is a 512 bytes. Okay, so you need to format your file system by block 0, 1, 2, 1024 blocks, like this. This is a formatting. So as if you are formatting your file system. So 0 to 1024 blocks. So your file needs 4 blocks as a default. Okay. Each block has the header information as we have discussed before. Like the file name is the first 10 bytes. File descriptor is a 4 integer. And permission and so on. And free block, this one will be used, this one is called file control block, header. This one will be stored, the header of the file system. This is usually called what? Directory structure. So we are going to use the one level directory, single directory. We have discussed several different directory structure, single level, multi-level, a cyclic graph, and graph structure. Among them, we will use directory. Single level, single directory structure. Each file will be stored at the directory structure as a FC. That is the file control block. Can you remember the PCB? Process control block. That include all the information about the process. So in the queue, for example, ready queue has the pointer of PCB, not entire process. Similarly, in the file system, you are not going to access the real file block. Instead, such a header information on the file control block, which means you need to define the data structure of the file control block also. File control block, file structure. Okay.
So that is just one block, so it will only occupy.
It doesn't have to be one block. It depends on. Okay. It depends on. It can be the multiple block if you keep the many information. It depends on how you design. That's just the example.
So Professor, how many spaces will the block occupy?
How many?
How many spaces will the block?
It depends on. We will see detail. Okay, but it depends on the file system. What kind of information you are going to manage. Okay, if you need only the file name, it will be just the 10 byte, for example. Okay, so but there are more information you need to keep in the file control block. We will see in the next slide. Okay, so this is the file system. Before that, we need to understand the different layer of the file system. So this is the hardware level. This is the application level. Okay? So in other words, when you access the data, so from your application, so your application program, okay, should know doesn't have to know the physical address. Instead, the logical information which will be stored at the file control block. Okay? Then this file control block has the information about the block ID, okay, and their physical block information. And ask this controller to access the physical level, okay, then finally in the secondary storage you can access the data. On reverse way, when you return the data, this is the external storage, hard disk drive. And the controller, disk controller, should be able to find such a data using the driver number, cylinder number, train number, sector number. Okay, just like that. When they return access the data, actually interrupt operating system and return data, then finally you can access. It's a different layer. Okay. Why do we need to use such a different layer of the file system? Kind of modularity, which means we can implement application program without considering this one. Sometimes we can implement such a basic file system using this I/O controller information. Also, if you want, you can develop device program, I/O controller program. Okay, so kind of modularity. So using layered approach, that is the reason this is kind of a highest layer. Using application program, existing file system, you can develop another file system. Okay, that is the layer, the file system. Because of that, you can some of the file system focus on the low level. Some of the files, the other file system focus on the application level, the file system. Okay. So each file system, their own format. For example, the CD-ROM. CD-ROM is also a file system. Okay, it uses the different file system. It's the ISO 9660. DVD has their own file system. Okay, and we have the FAT. It's a window. All the Windows use the FAT, FAT32. Nowadays, Windows 8 does not use the FAT32. Instead, NTFS. But Unix file system use ext1, ext2, ext3. It's a universal file system. So such a file system, so many file systems, but how does the operating system know each and everything? operating system provide kind of the virtual layer, virtual file system. That virtual file system should know the operation of each file system. So from one file system, it doesn't matter. Even though you do not know from the EXP2 access the data FAT, you don't have to worry about the detailed structure of this one. Through the virtual file system layer, you can access. We will see such an example later. And also, nowadays the Google file system and even database system has their own file system. Then now you can understand how application program provide the file system. It's almost application level. Okay? So this HDFS is the application running on top of existing file system application layer file system. So you can actually move in and out between the HDFS and your host file system. It's a separate command. Then each file system, when you implement the file system, it's not application layer, logical file system. That file system should have the different block, so including control block in case your file system has, your volume has the kernel module, it should have the boot control block. It point the address of your kernel. In case your file system does not include any kernel, it can be the empty. Doesn't matter.
But yes, the boot control block is the master boot drive.
Yes, it's the same thing, but it's a different master boot record. Master boot record.
MBR.
The MBR is used in Windows system, but it's the same thing. Okay. And each volume has the volume control block that includes the all information about your volume. So that will be the super block and master file table that include all the information about the block used in the file system. Okay.
So boot,
And also directory structure, yes.
so boot control block is something like what we have in BIOS, or as you mentioned, MBR.
BIOS. This is BIOS is the program on the chip. Okay, that is the first operating system. Then this one has the only pointer of the file system. Okay, that file system has the boot record, so automatically it's point to the boot. For example, this one is a CD-ROM. Okay, if we point the starting the media as the CD-ROM, CD-ROM is a file system. It has the boot record. So in case this CD-ROM has the image of kernel, this boot record has the address of your kernel. Okay, so that is a boot record. But not all the file system has the kernel operating system. At the time, it will be just empty. Okay? So in case from your file system, this BIOS program point this file system, but this one does not have the kernel. At the time, you can see the message. There's no available operating system image versions right there. So, what kind of information we can manage in the file control block? That includes this one. So, including file permission, please write to that. Last time we have seen the read, write, execution command for different groups. Such a permission will be stored at the file control block. And something the last create date or last access date and such a file date. And ownership and file size and for each file how many blocks are used. Okay, and additional block, such a block information will be stored in the file control block. So in your directory structure, you can copy such a file control block, then you can have the only file control block. Depending on the information that you are going to manage, the size will be varied. You need to define when you implement such a portable file system, I need a total 30 bytes. So you can create the 30 byte this file control block. You can assign one block for this project. Okay? Then one block will be used for one file control block. Then, who is the consumer of such a file? Who are going to use such a file in the operating system? User? Process. Okay? It's a process. Process will use your file. Then, what is a process? Process is in the memory. So, a process will create the file or open the file, access the file. Okay, so operating system need to manage which files are open, which files are created, which files are accessed by what? Process. Okay, per process we need to manage which files are used. Then, when we manage such information in the hard disk drive, it will be definitely slow. So we are going to use the memory. In-memory file system structure means such an addition. The file data structure itself is the physical. It's your logical data structure. Then, when operating system manage the file and the process, that information will be stored in the memory. So for example, this one, when we this is a kernel memory. So operating system assign the specific area for the memory and for the kernel. Okay. So this is your file system. When a process open the file, okay, then at that time it will specify open file is a system call. Okay. System call using the open system call. Then this file control block will be copied. Such a directory structure is in your secondary storage as a file, but once this file is copied at the open, this block information will be copied to the memory space for faster efficiency reason. Okay?
Okay.
So this is our file system that we create here. Okay? Then when a process open the file, okay, the operating system need to manage which files are open, which files are accessed, which files are changed. Such information will be managed in the kernel memory, not the secondary storage. To do that, whenever the file is copied at the open, we will copy the file. We don't have to copy entire file to the memory. Instead, file control block is copied to the memory. Then we'll manage it per process as well as system-wide. The per process means each process which files are opened. Also, at the same time, the operating system should know entire system. Okay, a file for the certain file which process are accessed. So this is a system-wide table, and this is the per process table. Operating system manages such information. Okay? Don't be confused with the file system structure. This is a structure that you define, that you create here. When a process accesses such a data, you can create the in-memory file structure.
So
Yes.
kernel memory is same as in-memory? Kernel memory?
Yeah, kernel memory is the memory space, but it's assigned for kernel information. You can specify.
Is it same as in-memory?
Yes, that means in memory. That's right. Okay. This is actually data structure for the file system, but using the memory for efficiency reason. Yes.
So that the one on the top happens when you open it, and the other one when you read it.
Yes.
Okay.
So these information are explained here. Okay. At that time, it's based on not entire file information. It's the FCD. The file control block will be copied and managed. just like the PCB is used for the memory, the process management. Okay, so last time we have talked about the such a mounting. So we can use the mount, okay, to adapt the existing file system. Okay, so you can create the mounting point as a directory. I'm not sure. Yes, this is an example. So you can the point. This is the mounting point, and this is the existing file system. You can connect the existing file system to the specific point. Then logically you can access the data from here. Root, then the control. And then virtual file system means, as I said, we have the many operating systems. So like we have the root, and this is the user. This is the test. This file system is based on the ext. This one is based on the UFS. So they are different file systems. They are different software. They have the different data structure. So how can access each one and each one? You can copy the file from the ext2 to the UFS file system. To address that problem, the operating system provides virtual file system. Virtual file system is kind of the common API. So this virtual file system understands all functionality, data structure of the each file system. So in case the application program copy the file, one file system to the other, this virtual file system provide such a information, how it is converted and changed. So that is the virtual file system. Most of operating system provide such a virtual file system. If you have the new file system, which is independent, then probably you need to contact the existing operating system and get the something certificate.
So, in real life, how does it work? Do they have a sort of agreed standard?
This they provide kind of, not standard, it's an API. It's kind of API they provide between two different file systems to access the data. So, for example, the read and write and the data structure. For example, how the FCB is designed in ext2 and how can be converted into the other file system.
So the virtual file system is supposed to have all the
information.
No.
Yes,
oh, yeah.
Sure.
So it's already preset, right?
Very sure. So in case of the portable file system, it's running on existing file system, so you don't have to worry about that file system is already the genuine in the virtual file system. However, if you develop the new files, total new file system, at the time, to be part of the operating system, you need to definitely follow the standard of the operating system. They provide, operating system provide such an API to work with the existing virtual file system. So this slide shows the diagram, how we can understand the virtual file system. That's the VFS level. This is the file system that you are using. Okay? NFS also is the same as the any other file system. Then the virtual file system is can be considered as a standard. Okay? Maybe. So it has when you open the file, it has open and close and read the data. I read the file. Okay. So such a functionality should be in the new file system.
Yeah. So we should use those commands, right?
Yes. I think they can be understood and standardized.
Yeah.
That would make sense. That's more makes sense. The standardized. Then that's the file system. Then what about the directory? So directory is based on the data structure that we have discussed the last time. It has a single level directory, multi-level directory, tree structure, cyclic graph, and the graph structure. Using such a whatever the directory structure we need to implement at the time. We need the main part of the directory structure is how to manage the file control block. Okay, when we have the many files, so how to organize such a file? So we can group or we can make the sometimes index. So simple implementation is just a linear list. So which means in the directory structure, so this directory structure manages the file control block. This file control block is linearly connected. It's very hot here. It's almost a sweat. A couple of weeks ago, it's very cold and snow, but suddenly changed it. And it's similar as how we can manage the data in the database system. But anyway, this is a linear list. So how can we search such a linear list? The brute force way. We need to connect visit each FCD until we find the FCD of the specific file. Okay, that is the linear, the list.
So
You can use yes. Yes, in case we have many. So at the time, if we can order by the alphabetical order of we can order by the file descriptor or we can order by the file length. Okay, then we can use the binary search. Also, as we have learned in the database, the indexing structure in the database, we have learned the B3 and B plus 3. We can use that, such as B3 or B plus 3. Another way of managing the FCD many file in the directory structure is we can use the hash table. I mentioned many times the hashing table in this class or the database class. I think that's the database class. What is a hash?
Hash table.
It's a hash table. What is a hash table?
You have a value and gives you your internal code.
So hash something use what? Hash table, hash indexing, hash whatever, hash file. Hash use hash function. So hash function. What is the characteristic of the hash function?
It will give you a specific object to the element you're looking for.
Input is
A key.
usually very complicated and very long, or it can be character whatever. Output
Point, yeah.
is a limited number, like the hash key, hash value. So we can use modular as a hash function. This is the most popular hash function. So whatever the input is, modular by 5. How many hash keys? 5 hash keys. So for the hash table, how many hash buckets? 5 hash bucket. 1, 2, 3, 4, 5. Hash value 0, 1, 2, 3, 4. So you can put for FCD that belongs to that has the same hash key. When you search, you can just apply the hash function for the A, B, C file name, modular by 5. Then this is the same. Somebody may be curious, how can you apply the modular to the character? How? You can
ASCII code.
ASCII code. You can change the ASCII code, then apply it.
No, but
Yes.
this you say when you modular by 5,
Mhm.
we get 5 hash keys.
Yes.
The same, all the 5 hash key belongs to the same file.
That is the collision problem. Any algorithm that use the hash function has the same problem, that is a collision. That means it's the same value in the same bucket, right? So how can we address that problem? There are solutions. We are not going to discuss the detail. You should be learned in your algorithm class. One of the solution is chaining. Another solution, hash over hash, and or extended hash. There are several solutions you can apply such a thing. Still, even though you do not apply, in the same bucket, you can do the linear search. How many? How much you can reduce? So just 20%, right? You can reduce using the
My
hash
question was,
function.
my
Yes.
question was that if we have 5 hash keys, so 5 hash keys has 5 different FCP or only one FCP?
This is kind of big bucket. This bucket, hash bucket, has the FCB.
For one file.
For one file, another file. All of this has the same hash value, hash key. Okay. So for example, I have the A, B, C, D, C, F, D, E, F, many files. Apply the hash function to this one. Then hash value is 1 of 0 to 4, right? So this one is 0, this one is 1, this one is 0, this one is 1. Then this file goes to this bucket, this file goes to the same bucket, this file goes to the 1, and this file is